Alright, so today's daily problem is nth Fibonacci number, and today is 24th April. Let's try to solve this problem. Fibonacci number. Okay, the Fibonacci sequence Tn is defined as follows: T0 equals 0, T1 equals 1, T2 equals 1, and Tn plus 3 equals Tn plus Tn plus 1 plus Tn plus 2 for all n greater than equal to 0. Okay, so basically, if you are familiar with the Fibonacci numbers, first of all, this is exactly Fibonacci number, but this condition, this sequence T0, T1, T2 is the same as Fibonacci number, but this Tn plus 3 equals Tn plus 1 plus Tn plus 2 is an extension of the Fibonacci number. If you are familiar with the Fibonacci number, you might know that Tn plus 3 will be Tn plus 1 plus Tn plus 2, but in Fibonacci number you have an extra term, right? The previous 3 terms. So we need to find Tn, and we have been given the n, right? N starts from 0 to 37. Okay, so there are a bunch of methods. We'll be going through all of them. First of all, we'll do the basic recursion. We don't even have to think about it. We just do recursion. If you are familiar with the recursion part, like what recursion is, so basically a recursion is a function which calls itself on smaller subproblems, right? So for n, we'll have to call n minus 1, n minus 2, and n minus 3. So yeah, let's just I'll do it here. Okay, let's write the base case. The base case is when n is 0 or n is 1 or n is 2, because we have been given that, right? If n equals to 0, return 0. If n equals to 1 or less than equals to 2, we'll return 1, right? For 0 we'll return 0, for 1 and 2 we'll return 1. Now we'll write our algo. Our algo is we have to return Tn minus 1 plus Tn minus 2 plus Tn minus 3, right? So we'll just return what? Tribonacci. Tribonacci of n minus 1 plus Tribonacci of n minus 2 and plus Tribonacci of n minus 3. Okay, what happened? Tribonacci of n minus 3, right? Yeah. So for 0 we'll return here 1, and 2 will return here. For 3, suppose it will call for 3 minus 1, which is 2, 3 minus 2, which is 1, and 3 minus 3, which is 0, and then we'll return it. Let's try to run it. Yeah, this is pretty much it for recursion. And since there are 37, n can go up to 37, and for every n we are calling 3 subproblems that we are not storing anywhere. So basically for every n, since we are calling 3 subproblems, it will be like for n it will be 3, for n minus 1 it will again call 3, for n minus 2 it will call 3. So it will be 3 to the power 37, 3 to the power 37, which is huge. Okay, these many calculations we cannot do in 1 second. We can only do 5 into 10 to the power 8 calculations in 1 second, or operations. So this should give a TLE. Let's just try to submit it. Yeah, it gives TLE, although it passes a decent amount of test cases, but still it's not the most optimal solution. Now what we can do is okay, we'll comment it. We'll do recursion with memoization. Memoization means storing intermediate values, right? So suppose we have found n-1. Okay, so let me explain it a bit clearly. For n equals to 8, suppose, we will call n-1, which is 7, we will call 6, and we will call 5, right? For 8 we will have to call 7, 6, and 5. Now when we are calling n equal to 7, we are again calling n-1, which is 6, 5, and 4, right? We are calling 6, 5, 4. So as you can see, we have called 6 and 5 2 times here, which is not acceptable, because if we have already found something, then we should not calculate it again and again. That is adding up to our time complexity. So what we'll do, if we have found Fibonacci of 5, we'll store it somewhere, maybe in a map or table, and then we'll reuse it. And reusing is because of one operation, it won't take 3 operations. Yeah. So what we can do is we can create a global variable in dp maybe, and since n can go up to 37, we'll make it of size 37, and what we can do is dp0 is 0, dp1 is 1, and dp2 is also 1. We initialize the the base cases, so we don't need these. And when we are returning, we'll store the value in n. So we'll do dp of n is equals to Fibonacci of this, and the base case here is if dpn is not equals to 0, then we'll return dpn. Okay, we made of length 37, n can be 37, so this should be n minus, no, not n minus 1, 38. Our size should be 38 because we are starting from 0 to 37, so 38, and yeah, rest is fine. You can try to run it. Okay. Initialization here won't work, right? So what we can do is we can initialize inside the function now. No problem. Okay, there is an overflow. Let us see. Okay, what can be wrong here? For 37, what test cases we have? 4 and 25, right? So for 4, 0, 1, 2 we initialized. If dp of n not equals to 0, we will return dpn. dp4, why not just initialize it in our function? How do you use memset? Memset str t size of str. Okay, memset dp comma 0 comma size of dp. We initialize it to 0 when we give the base cases. This is not needed because it is already 0. dp1 equals to 1, dp2 equals to 1. Now the base case is if dpn not equals to 0, then return dpn. Otherwise dpn is, yeah, okay. For 0, you see, for n equals to 0, dp0 is 0, so it will not return. So what we will do, or n equals to 0, because for 0 what it was doing, it was going 0 minus 1, 0 minus 2 and 0 minus 3, which is of course not possible. So yeah, it is taking a lot of time, but let us try to submit it. Okay, this time for 31 we are getting time limit exceeded. The possible reason may be because we have to initialize it. Maybe we can do it without this, because we are initializing it again and again. Okay, so I guess by default this value is 0. Yep. So as you can see, beats 100% and in memory beats 99.995%, which is very efficient, right? Both in space and memory. So yeah, this was recursion with memoization. We had to store all intermediate values, right? And the rest was same. So the catch or the take is, first try to make a simple recursive solution, and then you can memorize it very easily. You just need a data storing data structure and the base cases, and whatever you were returning previously, just write data structure at that point is equals to this one, and that's pretty much it. That is called memoization. You just memoized the solution. Okay, now we'll do the iterative part. Iterative solutions are generally faster than recursive solutions, so those will be more optimized. Let us see. Clear this. We'll do int dp n plus 1. Okay, we'll initialize it. dp0 is 0, dp1 is 1, and dp2 is also 1. Now we'll iterate. For int I equals to, we'll start from 3 because we already have numbers from 0 to 2. So from I equals to 3, I less than equals to n, and plus I, what we'll do, dpi is the previously, right? dp at I is dp at I minus 1 plus I minus 2 plus I minus 3. dpi is dp I minus 1 plus dp I minus 2 plus dp I minus 3. Yeah, and that's it. We'll just return dp of n in the end. So yeah, we initialize 0, 1 and 2 as the given base cases, and then we start a loop from 3 to n and just use the previous calculated values to store here, and then return the n. Let's try to run it. Yeah. N was 0. When n is 0, or n plus 1 will be 1. Okay, so when n is 0, we won't be able to initialize dp of 1. When n is 2, we won't be initialize the dp2. So what we will do, if n is 0, then we'll return 0, or if n is less than equals to 2, we'll return 1. Now this should work. Yeah. So yeah, the space complexity is the same as that of the previous one, recursion with memoization, but I guess because we are initializing the array inside the Fibonacci function, and Leetcode servers are trying to maybe they are recalling the function again and again, so maybe this array is getting duplicated again and again. That's why it is giving us low space complexity. But as you can see, the time is 1 milliseconds, which is fast enough. Yeah, there is one more solution that is even better than this one. Let's have a look. It is also iterative. I like to call it the variable dp. Okay, so you see, we only need previous 3 values and the current value, right? So we need previous 3 values and one current value. We don't need to store all the values, right? All intermediate values. We just need the previous 3 values. So what we'll do, we'll initialize. We'll do int, maybe t0 is 0, t1 is 1, t2 is 1, and t3. And what we'll do, we'll run a loop for int I equals 0, I less than equals to n plus I. What we'll do, t3 is t0 plus t1 plus t2, and now t0 will go, right? It's like it was t0, t1, t2, Now we have T3. So because we need only these for calculating T4, we will get rid of this T0. So T0 will become T1, T1 will become T2, and T2 will become T3, right? So what we will do, T0 equals T1, T1 equals T2, T2 equals T3. Yeah, and and then T3 will be recalculated. This will happen n times, and then we will return our T3. So okay, let's go through it one more time. 0, 1 and 2 we have. Suppose we want to find for n equals to 3. So first of all, the loop should start from 3. N equals to 3. Yeah, so T3 will become this will happen, and the loop will end, and then we'll get T3. Let us try to run it. Okay, oh my bad. Yeah, this should work. Okay, for n equals to 0, you see, for n equals to 0, for n equals to 1, and for n equals to 2, this loop will not run, and because of that T3 will be this random value. So we can just do, if n is 0, will return 0, else if n is less than equals to 2, will return 1. Let's try to run it. It is running. It should submit also. And yeah, 100% in time, 81% in space. So yeah, that's it. These were the all 4 types of solutions that you could have come up with. And yeah, that's how you do it. Thanks.